So as we know in yesterday's class, we discussed extraction of metals low in the activity series, how we can extract. And next one, metal moderately reacting metals. Now today's class we'll complete that moderately reactive metals, and then we'll see that highly reactive metals, how we can go there. So first of all, let us revise quickly. Extraction of metals low in the activity series. So for this, what is the examples, guys? I told you. Low in the activity series means you have to make two examples according to the book. So what is that? All of you. One is copper, another one is what? Mercury. Okay. So for this one, what do you have to do? So normal process, we people cannot extract the things. So the way we can extract the metals which are low in the activity series is the first one. We have to increase the concentration by using a what process? Everybody? By using fourth flotation process. That is what concentration, fourth flotation process. We people can increase the concentration of the ore. And then second process, at a time we have to do it what, guys? Roasting, and followed by what, everybody? Reduction. Roasting is followed by reduction. Even this point is not even required for us. The main point is roasting and reduction only. So roasting means what, guys? In the presence of oxygen or absence of oxygen? Everybody?
Presence of oxygen.
So presence of oxygen means in the presence of oxygen, if you burn the metal source, then it will be converting into, by roasting process, what is the first step? We'll converting into oxides, and then again continuing the heating, it will be converting into what? Metals. Understanding? So that is what we have to do it. After that, still we won't obtain the pure metal. So we have done one example. So if I have taken, for example, mercury. So what is the source of mercury? Mainly what is that sources? Everybody, the ores are present in what? These metals. In the form of sulfide ores, and as well as mainly it will be present in what ores? They will be present in the form of sulfide ores. Am I right or wrong? So if you take mercury, so what is the sulfide ore of mercury? Everybody? Mercuric sulfide, that is what we used to call as what? Yes. So we used to call it as cinnabar. So what is the equation? We have done that. So mercuric sulfide, cinnabar, if I start heating in the presence of oxygen, that is what? Roasting. So that first it will converting into what? Sulfide ores will converting into what, guys? Sulfide ores will converting into what? Oxides. Yes, so it will be converting into mercuric oxide, plus we will get sulfur dioxide gas. Now, this mercuric oxide, if you are continuously heating, if you continue the heating, and then they undergoes what? They undergoes the metal. So mercury plus oxygen will come. So this is the process only we used to call as. What we used to call, guys? This is reduction. And this is called as? Reduction. Everybody, roasting process. So balancing equation, this 2HGS, 3O2 gives us 2H2O plus 2SO2. Am I right, everybody? I think everybody familiar. We have done yesterday's class the same thing. Am I right, guys? All of you? Yes, that is what. So same way, like we can do it for copper glance. This is mercury mercuric sulfide. That is what we can say cinnabar. And copper glance also, Cu2S. Copper glance also we can make it. Remember formulas, if you make mistake, no mark will be awarded. That is why please learn the formulas always and give preference to that. Write the equation and practice it. And then we have done two more metals that is what we are presently continuing. So after that, we are obtaining the metal, but of course, this metal is a not pure metal. So we will go undergoing something. For example, copper. So extraction of copper, we have done that, everybody. What is that? For purification, that is refining. Understanding? So what is that? We will go that, everybody. So refining the metal, yes. So for refining, we will go what process? Electrolytic. Later on. So your electrolytic refining of copper. So always here we have done that. Always remember pure metal strip has been connected to anode or cathode. Pure metal strip has been connected to anode or cathode. Everybody.
Cathode.
Cathode. Understanding? So pure metal strip has to be connected to the cathode. So that is why we will obtain the pure metal at cathode or anode. Everybody. We'll obtain pure metal at cathode. Understanding? So positive charge. This is what anode. So anode we have to put what? Impure metal or pure metal? Anode. Pure or impure metal? Impure metal. So that from the impure metal, the pure metal will dissolve in the electrolyte solution. What is the electrolyte solution? We have to take it, guys, in this process. Yesterday book also have shown you. What is the electrolyte we have to take it? Anybody know? Yes. Acidified salt. Who is that nonsense making a disturbance? Please check that. Acidified. So acidified, to make acidified, what acid will add? Everybody. Sulfuric acid. So acidified copper sulfate solution. If it is copper sulfate solution, we have to use it. What is the copper sulfate solution? Everybody, formula? Yes, please. CuSO4. Okay. So then what will happen? The copper will dissolve and it will lose the electron and they will move towards to the cathode. And here they will gain the electrons and they will turn into copper. So that is what in this always will get two reactions. One is anodic reaction. Another one is what reaction, guys? Everybody. Anodic reaction and another one is cathodic reaction. So the most important one, anodic reaction and cathodic reaction. At anode, they will lose the electron. So copper is going to lose the electron and it will, suppose copper means it will give 2 electrons back. And the same copper ions will come and they will receive the electrons from the cathode and they will again turns into the copper. This is the copper atom. So this is the purest metal which will obtain at the cathode. So that is why when the electrolysis process is continuing, we can notice that the thickness of the anode is decreases or increases. Everybody. The thickness of the anode is decreases and the thickness of the cathode is, everybody. Increases. Cathode is increases. Do you all understanding, everybody? So increases. This is what we have studied then. Then we have made it extraction of metals middle in the activity series. What is the 2 examples for extraction of metals middle in the activity series, everybody? Extraction, yes. Extraction of metals middle in the activity series. Everybody? Yes, please. What are the 2 examples? Activity series. This is what very toughest process. Many things we have to follow. So what are the 2 examples, guys? Zinc and iron. So for this one, many steps are involving. So what is the first step? Extraction of zinc. Already we have done that. So they are moderately reactive metals. So for this one, we have to convert first. Conversion of, if it is a carbonate ore, basically these are present in the 2 kinds of ores. What is that? They will present in either carbonate ores and sulfide ores. So what is first thing? We have to convert this carbonate and sulfide ores into what? Everybody?
Oxide.
Yes. So conversion of carbonate and sulfide ores into oxides by using what process? Not roasting. By using what process, everybody? By using please respond, calcination process. Means in the absence of oxygen or the presence of oxygen, everybody? Absence of oxygen. That is also which one? Carbonate ores under calcination. But sulfide ores always what? Everybody.
Roast.
Sulfide ores
Roasting.
always roasting. Please remember, carbonate ores only will undergo calcination. Sulfide ores means again same. So calcination of zinc carbonate is the ore. What is the common name of zinc carbonate? Anybody?
Calamine.
Name of zinc carbonate, calamine. Mr. Kaushik, are you there? Are you writing? So it will turns into zinc oxide plus carbon dioxide. Same way, if you take zinc sulfide, that is the sulfide ore. So this is only called as, what is the common name? Everybody, zinc blend. So which will react with the roasting, guys. This is not calcination. So undergoes roasting. So roasting means presence of oxygen or absence of oxygen. Everybody. Presence of
Presence
oxygen, so that they will turns into zinc oxide plus sulfur dioxide. So now these things, after converting the carbonate, okay, carbonate and sulfide ores into oxides. See that carbonate ores converting into oxides, sulfide ores are also converting into oxides. What is the step 2, guys? Anybody can tell which step it is? It is not easy one. Moderately reactive metals, many things we have to take care. What is that? Look into your book. What is the next one? Converting after converting into oxides. What else we have to do, guys? We undergoes reduction by something. What is that? Everybody.
Coke.
Reduction by carbon. So reduction by carbon means in the sense of, in the form of what we'll use? Carbon in
Coke.
form of,
Carbo.
okay.
Coke or
this
coal.
one. So if you undergo the reduction reaction, so sometimes displacement also will goes. That is what example of what yesterday before ending the meeting I told you. Sometimes we'll undergoes displacement also. What reaction it is? Reacting with aluminium. Am I right or wrong? Everybody? So first let us see
Yes,
with
sir.
reacting with the carbon. So zinc oxide reacting with the carbon, that is what by reduction process. So carbon is a strong reducing agent. So which will gives us zinc plus carbon monoxide. But this carbon monoxide is very dangerous. So for further process, what will happen, guys? The CO carbon monoxide further used as a what? Further be used as a what? Everybody, reducing agent. Remember, carbon is the strongest reducing agent. So zinc oxide will react with the carbon monoxide gas. So it will produce us what, guys? Anybody can tell? All of you. It will produce zinc plus carbon dioxide. So for this one only overall reaction I have taught you. So what is the overall reaction? Everybody speak loudly. Zinc oxide reacting with the carbon. So we are going to get what? Zinc plus carbon dioxide. Am I right or wrong? Everybody? Please
Yes,
respond,
sir.
girls. Girls, understand everybody? So balancing equation 2ZnO plus C will gives you 2Zn plus CO2. So this is still here I taught you in the yesterday's class. So these both are internal reactions. You have to remember that. First carbon monoxide produce this carbon monoxide further reacting with the zinc oxide. That is what as a reducing agent. And then they will produce just zinc plus carbon dioxide. So that is why we will write it. This is the overall reaction of reduction of zinc oxide by using a carbon. That is what carbon means. Either coke or coal we will use it. Is it okay, everybody? Clear? All of you? Mr. Omar, please respond. Harish, Harini, Johan. Yeah. So that is what. Next, there is another element. What is that, Mr. Nimish? Middle. Middle means two elements are there. One is zinc, another one is what, guys? Everybody. Second one, iron. So reaction of iron. So of course, if it is sulfide ores, we have to convert into what? First step. If it is a sulfide ore, we have to convert into what, guys? Please respond.
Oxide.
Yes, oxides. By what process?
Roasting.
Yes,
By
by
roasting.
roasting. If already is there, check the iron ores. Iron ores, we have directly what? Iron 3 oxide. Is there any sulfide ore is there for iron? Anybody?
No, sir.
No. So directly we are already having oxide ore only. So even carbonate ore also not there. Am I right or wrong, guys? Everybody? Yes. So is it necessary for calcination and reduction roasting process? That is what is my question to you guys. Is it necessary for
No,
roasting
sir.
and calcination for iron? Am I
No,
right?
sir.
No, because iron is already existed what? Check your all of your tabular column. Iron is already existed what? In the form of
Oxide.
oxide ore. So it is already existed in oxide ore. It is not necessary that you need to undergoes roasting or reduction process. Sorry, roasting or calcination. So directly I can go what, guys? Reduction process. Am I right or wrong? So for extraction of iron, you can write neatly. Extraction of iron, calcination or roasting is not required. Why, guys? Everybody? Because respond. Already iron ore is existed what? Yes, please.
Oxide.
Yeah.
Oxide form.
Already iron ore is existed in the form of what? What is the name? Tell me. Iron 3
N3 oxide.
iron 3 oxide. What is the name of iron 3 oxide? Everybody? Fe2O3. Okay, that is what. Somebody's noise is coming. Yeah. So directly write the equation, guys. All of you. What will happen? Fe2O3 reacting with the carbon. Okay, carbon. So tell me, all of you, what is the products will come? Heat. If you heat it, speak loudly, Ra. We'll get iron plus we'll get carbon monoxide gas. So carbon monoxide. Then further, who is the reducing agent? Everybody.
Carbon monoxide.
Yes. Carbon monoxide will be used as a further reducing agent so that this carbon monoxide gas balance the equation. 3 carbon gives you 2 iron plus 3 Cu. So, and the heat will further continue so that what is the products will come? Everybody. Iron plus respond 3 CO2. Understanding, Amma? All of you? Girls? So now, can you tell me what is the overall what is the common name of this one? We also can say iron 3 oxide. Also, we can call it as what? Everybody. We can say ferric oxide. Mr. Yes, understanding, Mr. Vijay? That is what. So everybody tell me what is the overall reaction? Mr. Pugal will say. Pugal, can you tell me what is the overall reaction for this one? Try to form it like a zinc oxide. Just simple. Anybody? Please respond. What will happen? Fe2O3 react with the carbon so that it will form no response at all. So it will give iron plus carbon dioxide. Now I'm giving chance for girls to balance the equation. Let me see boys or girls who will balance. Overall equation has to be balanced. Before zinc I balanced it. Now you balance it. Make it quick. Let me see who will balance first. I'll wait. Girls or boys, everybody try. Try. If you try only you can. Right or wrong secondary. First, there must be a resolution. Yes, I should answer. I want it. That is the spirit you must have. Omar, only good morning message or any other thing is there? Please make it quick.
Sir, 2 Fe2O3.
Yes. Others, no girl is
3C.
there. Okay. 2 Fe2.
3C.
Very good, Mitakshree. You wait, girl.
Gives
You wait,
Fe
Mitakshree.
plus 3CO2.
Yes. 2 Fe2O3. 3C. Yes.
Fe plus 3CO2.
No. 3C. Fe wrong. Any other, Mitakshree?
4Fe.
4Fe.
Yes, 4Fe plus 3CO2. Boys also, everybody balance it. Balancing equation, see, by this time you must have attained this skill. We practiced many equations. So please kindly look into that. Hundreds of equations we are practicing. That's what I'm expecting always from you people. You have to undergo complete, like mind itself, you must balance it at certain stage. That many equations we are practicing. So consider that and make it. Okay. So now this is what reduction process. So reduction. So iron extraction of iron does not need calcination or roasting because already it is existed in the form of oxide ore. If it is already in oxide ore, directly we can go with the what process? We can go with the what process? reduction. Understanding? So reduction with the carbon, we have done it. So carbon means coke, we'll use it. But instead of coke, we can go under with some other thing. That is what book they mentioned very clearly. So we can go with the what, guys? Everybody. We can react
Aluminum.
with the displacement reaction. What is the displacement reaction? We can show that. Reacting with the
Aluminum.
what is that? Check it, everybody. So the highly reactive metals such as sodium, calcium, and aluminum, etc., are used as what? Used as reducing agents because they can displace the metal of lower reactivity from their compounds. So this is only the example for what? Displacement, everybody. Displacement reactions. And this is one of the best example for exothermic reactions, and this is very popular equations. That is what we used to call it as what welding, everybody? Thermite welding. So the most important one. So iron oxide, keep it in mind, iron oxide or ferric oxide, instead of carbon, if you undergo reduction with that is what reducing agent, another reducing agent if you use, that is what we will use basically. We can use any metal. According to the book, we can use what metals? We can use it sodium, calcium, and aluminum, etc. More reactive metals. But reacting with the sodium and calcium and all is very tough. It's very dangerous also. It's a extremely highly exothermic. So better we'll choose with the what, guys? Reacting with the what? Everybody.
Aluminium.
Yes.
Aluminum.
So reacting with the aluminum. So that is only necessary for us. So you can keep it heading and you can write it. So reduction by aluminum. So instead of carbon, we can go with the what? Reduction by aluminum. So this is the most important reaction which we used to call it as a thermite reaction. Understanding? So this thermite reaction is used to join the what? Rail tracks. Understanding, Amma? So in welding of railway tracks and broken parts of machines, they will use the same equation. So because extremely huge amount of temperature, huge amount of heat will release. So that is why it is exothermic or endothermic. It is, everybody, exothermic reaction. So
Exothermic.
even first chapter itself we studied that. Am I right or wrong, everybody? So that is what it is. So there is a two metals we can take it, but thermite welding means mostly people will remember iron. So ferric oxide, again and again I am writing the names. So ferric oxide reacting with the aluminum, so that what is the products will come, guys? We are getting liquid iron. Liquid iron, we should call it as something. What is that? Any metal will melt, we used to call something. What is that? Molten. And we are going to get aluminum oxide, plus we are going to get heat. Boys, balance it fastly. Don't see the book and balance. Make it fast, boys. Mr. Omar, Sanjay, Noor, Nimish, no response at all, Nimish. Rohit also. Rohit, balance fastly.
Sir, 2Al.
Unless you try, there is no change. I am saying you. You people should work. You people need to work. Yes, please.
The 2A. 2 if you
That Hiranmai, are you writing? I want response. Hiranmai, are you doing? Yes. Boys, tell me, Ra.
2FU2.
2Al plus 2Fe. That's all. You must work. I want to see that. Okay. So don't copy from the book. You must try. That's what. Now, instead of ferric oxide, also we can use another one. What is that, everybody? This is only till now hidden equation. Till now, many people don't know this equation is existed in book also. That is what? Manganese dioxide. Now it is very popular. Why? because this question asked in sample paper. Am I right or wrong? So thermite welding means people will consider only this equation is a thermite welding. But this one came in only first time in the CBSE history in the sample paper. So manganese dioxide. So manganese dioxide reacting with the aluminium. So what will happen? Here and I called you, but no response. If no interest, leave from the meeting. No issues. So react and it will form. Instead of iron, it will form manganese metal, molten metal. See, I am writing liquid molten metal, and it will form aluminum oxide plus heat. Now, I am giving chance to girls to balance it and boys to generate a CBQ from this. Anybody, boys? Boys generate a CBQ from this, and girls will balance this equation. Girls, make it quick. Boys, you undergo generating CBQ. From these two equations, you can generate a CBQ question. Let me see who will generate the CBQ. Instead of thermite welding, I may ask some other way. Anybody? What is the way of asking questions? Mic is not working. You should answer in chat, and you have to involve. I want to check it everything here and my no excuse at all. Yes, please, guys. Some people are having disturbance, so please rectify it. If it is disturbance, no need to speak. You can chat. You can text in chat.
So 3M.
Yes, please.
3.
Harini, answer Harini. How many times I should call you? Tell me right or wrong, no problem. Girls,
3MnO2.
3MnO2,
4Al.
4Al gives you 3Mn plus
2Al2O3.
2Al2O3. Learn it. Boys, anybody generated any question from this? CBQs. Girls also can answer. What is the CBQ question you can ask from this? There is an intelligent question. Very simple question, but you people can ask means I cannot answer. Today you might be remember, but tomorrow you will ask means nobody. Mr. Noor, Sanjay, Mr. Omar, I am calling you. Only good morning message. Don't text me and don't call, say me. I am asking you question now. Tell me. Harish, what is your expected question? Gayatri, anybody? Harish Jaras? By seeing the physical state itself, we can ask guys question. Anyone? At least now I given clue. Nidakshri? Okay. So write the question, I'll say it. Like for example, let me choose. Yeah. Man is in the I state. Yes, Manikandan got the question. So write the question. In these both equations, they will ask you the equation. So you can notice it and you can write it. So what is that? See that. Write the question. Let me choose with a name. Right, you can write it. Okay, write with the Rohit name. Right. Mr. Rohit, notice that Mr. Rohit noticed that when he is performing the chemical reaction, or you can write reduction reaction. When he is performing the reduction reaction, he has noticed that a molten metal is coming as one of the product, write that given equation, identify the chemical reaction and balance it. So by the time we are having two options. One is either ferric oxide or manganese dioxide reacting with aluminum, because in this both the cases we'll get the molten metal. So molten metal. So based upon the molten state, so they will ask you, there is a possibility of asking CBQs. So now the way of asking style is maybe different. Some other things, even particularly they may be specifies. Understanding? Mr. Rohit is noticed that 2 moles of molten state, molten metal is coming when he conducted the reaction, chemical reaction in the laboratory. Do you understanding, everybody? So particularly 2 moles of molten metal. 2 moles of molten metal means what is that? Definitely it is a what? Everybody, iron. If it is a 3 moles of manganese, then it is manganese, you have to write it. So there is, based upon the balancing equation also they will ask you. That is the reason I am saying balancing equation has to be trained well. Within a second you must able to balance it, because CBQs, many questions they will ask you from the balanced chemical equations. Everything you have to see in the aspects of CBQs. That is the reason I am saying you every balanced equation. Please understand that and write it. Even including the carbon monoxide reaction, it is there in the book. Do you understanding, everybody, guys? Carbon monoxide reaction is there or not in our book? Verify it. Is there or not? Intermediate reaction. Yes or no? Everyone. And then only further it will be goes. Am I right, Harish?
Yes, sir.
Yeah, first it is there carbon monoxide only. That carbon monoxide is reacting further so that it will converting into zinc. That is what is they have given. You can check it also. So that is what. So next we are going to study extraction of what? Third kind of metals. What is the third metals, everybody? Extraction of metals which are, make it quick. Yes. So extraction of metals which are high up in the activity series. High up in activity series. What is that examples? High up means activities. Potassium, sodium, calcium, magnesium, and as well as what? Aluminum. So this all the metals, simply you people can extract it by a single step. What is that, everybody? Highly reactive metals. So highly reactive metals means directly we can obtain by the what process? We cannot obtain. Yes. So these are oxides and halide ores. So basically this highly reactive, what is the ores? Either oxide ores and halide ores. Am I right or wrong? Everybody. So either oxide ores or halide ores, they are present. So they cannot be reduced. They cannot be reduced by what process? Everybody. They cannot be reduced by heating with the carbon. So they undergoes what reaction? Directly electrolytic reaction. So the reduction of these compounds, electrolytic reduction method. So we cannot be reduced by heating with the carbon. So only they can be reduction process done by what, guys? Reduction of these compounds. Write it. Compounds directly, simply I can go with what? Undergoing, everybody, electrolytic reduction. Okay, so directly I can go electrolysis process. So now during this process, electric current is passed through the what method? Molten salt of the metal. Keep it in mind. So electric current is passed directly. Electric current is passed through molten salt. What do you mean by molten salt? Anybody? What do you mean by molten salt? Any one of you? Molten salt means melted salt. Melted salts of, that is what, either oxides or halides. Okay. So one of the example, best example, sodium chloride. Already sodium chloride, the aqueous sodium chloride and aqueous sodium chloride, second chapter will come. Molten sodium chloride I have taught in the first chapter. Anybody can tell me examples of exothermic reaction? And aqueous sodium chloride is an example of something which will come in the second chapter. Anybody? Aqueous sodium chloride. Yes, chloralkali process, second chapter, for production of sodium hydroxide, caustic soda. Do you remember, everybody? All of you? Electrolysis of aqueous NaCl, but here is not aqueous NaCl. What is that? Molten NaCl. Chapter 1, you will study that for under the electrolysis process, thermal decomposition, electrolytic decomposition. So NaCl, two reactions we can do for electrolysis. One is aqueous NaCl. So if you do the aqueous NaCl, what is that, guys? That is the process name called as aqueous NaCl. We used to call as chlor-alkali process. Second chapter will get it. Am I right or wrong, everybody? Second chapter, production of caustic soda. What do you mean by caustic soda? Anybody? Caustic
Sodium
soda sodium hydroxide. Understanding? And again, one more example I told you, electrolysis of molten